My students are having difficulty purifying this liquid product.
Well, we know high boiling organic liquids undergo partial or complete thermal decomposition at their normal boiling points, right?
And if we reduce the pressure of the distillation, we reduce the boiling points of the liquid.
So,
vacuum distillation.
Let's check on the stagehands.
Distillation under reduced pressure is recommended if the normal boiling point of the liquid is greater than about 150 degrees Celsius. Before carrying out a reduced pressure distillation, decide what reduction in pressure is required. As a general guide, halving the pressure will reduce the boiling point by about 20 degrees Celsius. A water aspirator vacuum of about 20 torr will reduce a boiling point by about 100 degrees Celsius, while a vacuum pump with a vacuum of about 0.1 torr will reduce a boiling point about 150 degrees Celsius. Frequently, vacuum distillations demand a better vacuum than that which can be achieved using a water aspirator. In such a case, an oil immersion vacuum pump is used. The pump has a rotor which is concentric with the motor drive shaft mounted within a cylinder. A seal is maintained between the blades and the cylinder wall by a thin film of oil. On turning, the rotor blades cut off pockets of gas and sweep them through the pump to be exhausted by an oil-sealed non-return valve. Normally, the pump is never allowed to work while open to the atmosphere, since continuously drawing air through the oil in the pump will cause water vapor to be trapped in the oil, which will reduce the vacuum that can be achieved. Since the oil is always diluted or decomposed by organic vapors passing out of the distillation apparatus, an oil pump must always be used with one or more cold traps to minimize frequent pump oil changes and repairs. To protect the pump from condensing reaction vapors, a cold trap is placed between the pump and the distillation apparatus. The trap is cooled with a solid carbon dioxide acetone slush bath at -78 degrees Celsius. Liquid nitrogen should not be used since condensed oxygen may become a dangerous explosion hazard. The pump is connected to its associated equipment through one or more cold traps and a manifold which has ports for connecting a manometer, distillation apparatus, and manostat or bleed. A manifold is used to permit isolation through a two-way tap of either the vacuum pump port, the manometer port, or the distillation apparatus port at any one time, or to allow all to be interconnected. A manometer, most often a McLeod gauge, is used to accurately measure pressure between 0.05 torr and 10 torr. To read the pressure within the system, the manometer gauge is rotated to the vertical when the mercury enters the two arms. The gauge is tilted such that the meniscus of the mercury in the right-hand arm touches the zero, and the pressure is read off from the left-hand arm. The manometer should always be kept in the horizontal position when not being used to measure pressure. A manostat may be used to maintain a constant pressure in the system. It operates as a valve between the distillation apparatus and the pump, keeping fluctuations in pressure very small. Alternatively, nitrogen or air may be bled into the system at such a rate to maintain the desired pressure. This technique is less desirable since air causes decomposition of the pump oil and decreases the efficiency of the pump. Check that the two-way tap between the trap and the pump is closed and that the trap is empty. Close the two-way tap between the pump and the manifold, then turn on the pump. With all ports closed on the manifold, open the manifold to the pump and allow the vacuum to stabilize. Immerse the trap in the dewar and fill the trap with an acetone dry ice slurry. Open the manifold to the manometer to check that the vacuum is satisfactory. Rotate the McLeod gauge to the vertical. And record the pressure reading, noting if the pressure is constant and whether there are leaks in the system. Tilt the manometer back to the horizontal. Then close the port to the manometer. The glassware apparatus for vacuum distillation is shown here. The apparatus requires the use of suitable flasks that will withstand being evacuated. The flasks should be checked for star cracks or deep etches before use. The apparatus uses a Claisen still head and a modified receiver adapter which allows you to change the receiving flask to collect another fraction of distillate simply by rotating the adapter without the need to remove the previous flask. The glassware is assembled using vacuum grease to seal all joints. Then a check is made again for leaks. Position the heat source. Pour the sample into the distillation flask, remembering no more than 2/3 full. And add a stirring bar. You need to ensure that the liquid boils smoothly without bumping. Brisk stirring using a stir bar and magnetic stirrer is preferred to prevent bumping, since boiling stones do not function under vacuum. Place the flask in the heating mantle. Build a distillation flask by clamping the Claisen still head in place. Clip the flask and still head. Position the thermometer. Position the condenser clamp. Add the condenser. Clip the condenser to the still head. Add the stopper to the still head. Add the receiver adapter and flasks. Clip the receiver adapter to the condenser. Connect the apparatus to the vacuum pump through the appropriate manifold port using the black hose. Then carefully open the manifold port to the vacuum. Stir the liquid rapidly. Some bumping and frothing may occur as volatile components are evacuated. Regulate and adjust the pressure to the required value. And if necessary, open the bleed to allow inert gas into the system. Heat the flask slowly to drive off traces of volatile impurities, and slowly distill the liquid, all the while monitoring the still head temperature. First, collect a volatile's fraction. Then, the main fraction, which should distill at a fairly constant temperature. Slow and steady distillation is best when collecting several fractions. Remember to record the boiling point and the pressure of each fraction. Stop the distillation when the level of liquid in the distillation flask is low by removing the heating bath. Allow the apparatus to cool to room temperature before releasing the vacuum. Release the vacuum by closing the manifold port to the pump. Carefully fill the apparatus with inert gas by slowly opening the bleed port on the manifold. Remove the flask and dismantle the distillation apparatus. Open the manifold port between the pump and the system and clean the cold trap. Let us review the steps in carrying out a distillation at reduced pressure.